Okay, quick refresher on spots. That's called the what? Base. What's that spot called? The argument. And what's this spot called? The exponent. Because if I rewrite it, it's 3 to the x equals 5. Now, which one of these two forms is better? Well, one of them is solved. Is the green or the red one solved? Well, which one has the variable alone? Because that one's solved. Does the green one or the red one have the variable alone? The green one. So the green one is solved. It's done. That's why we won't have any like that today, because they're already solved. Or if we do have them, all you got to do is simplify them. And you could put that in a calculator and know what the answer was. I don't need to do anything else. X is already alone. This kind, you'd have to rewrite to look like this kind because the variable isn't alone yet. All right. But just a quick reminder that that's called the base spot. And this kind, that's called the base spot. This is called the argument spot. This one doesn't have an argument. That's only with logs. And then this is called the exponent spot. Makes sense. It's in the exponent position, right? That's the exponent. On a log, the exponent is what it's at the very end. All right? So, to make sure that you understand that, I'd like you to label this with A is called this, B is called that, and C is called this other thing. What's A, what's B, and what's C? Because if I'm talking about the argument and you have no idea which one it is, so please label these. Right now you should say A is the blank, B is the blank, and C is the blank. I labeled these with letters that weren't nice on purpose because I want you to make sure you don't just think, whenever he puts an A, that's going to be the argument. Get that brain going from this weekend. Mr. MK, what did you say A was? That is the base. You are correct, sir. What did you say B was? Okay. And that's not right. The B is not the exponent. The B is called the argument. You guys should argue about that. And this lastly, the C here, Mr. FR, that's called the exponent. Learn it. This one's the base. This one's called the argument. That means you can rewrite this thing with just A, B, and C. Please do that right now. You need paper. You can't just sit there. Okay. So you got an A and a B and a C. Dice of Destiny. Who am I supposed to call on here to figure out what they did for a rewrite? Row 6, fourth person. 1, 2, 3, fourth. That's you. What to the what equals what? A to the C equals B. That is correct. The base is this number. All right, so that was a little harder because it was variables. Let's do it with numbers. Now, would you please rewrite that? If you know nothing else, you've got to know how to do these rewrites. Something to the something equals something. Now, this one is not solved. Somebody tell me, why is this one not solved? The X is not by itself. Good. Row 4, person 1, equals, all right. Now is X alone? Yeah, so it's solved. So half of today is just the rewriting thing. You just got to take stuff, rewrite it, and X will be alone, and then it's solved. I have no idea what 3 to the 8th is. It's a lot. I can tell you what 3 to the 4th is. A lot of people don't have that memorized, but it's really not that bad because it's 3 times 3, and then 3 times 3, and then it's 9 times 9. So what is 3 to the 4th? 81. And then you go times 3 again, which starts getting tough to do in your head. And then times 3 again, and then times 3 again. So anyway, 3 to the 8th is huge, but it's the answer to this question. And if you type this in a calculator, First of all, you can't type that on a calculator. So you'd have to know enough to write it like that, and that you could type on a calculator. See how calculators can't solve everything for you? All right, and in a typical homework problem, we would not have this one. We would have made the 8 much smaller so that you could do it in your head. Like, let's say we had this be a 4. Then you could have done 3 to the 4th, the way I just showed you. 3 times 3 times 3 times 3, and it would have been, do you remember? 81. Okay. All right. So that's where the x was in the argument position. What if the x is in the base position? Would you please write this one? And then rewrite this one. Did you get x to the 8th equals 2? It's not real nice, but it's right. Now, this one's going to take one extra step to solve. And please don't say times it by 8, or even times it by 1/8. That's not the right way to say it. You get that there's a 1/8 involved. And it's called putting it to the power of 1/8. Raise your hand if you knew that. Awesome. Then you passed last chapter's test. Okay, so then 2 to the 1/8. I have no idea what it is. It's the 8th root of 2. Some people write it like this. It's totally okay to do that. If this test doesn't allow calculators, which it doesn't, then you'd have to leave your answer that way. Nobody knows. Nobody's got the decimal memorized for that. Now, had it been the 3rd root of 27, then that you're expected to know. What would the 3rd root of 27 have been? 3. Okay, good. All right. So I think I'm ready to get into this thing and go through it pretty quickly. You're going to solve this kind and this kind. Why aren't you going to solve that kind? Because it's already solved. X is already alone. See how the x doesn't have anything yet by it? So then the answer is log base 2 of 8. That's an answer. In fact, that's a particularly nice one because do you remember that pattern where this 8 could be rewritten as a 2 to a power? What would it be? 8 would be 2 to the 3rd. And why is that smart? Because these two are the same. So the answer is what? 3. All right, let's go through some of those patterns again. Log base 6 of 6 should be really easy. That one's 1. Because it's the exponent. If these are the same, the answer is the exponent. What's the exponent? 1. And if I say equals x, I hope you get that this whole thing equals 1. You can replace it with a 1. 1 is x. Okay. All right, how about this? Log base 6 of 0. Don't get this one confused. Is this 1 the argument? No, there's not a 1 in the argument. What's the answer to this one? How about this? I'll prove it. I'll say equals x and I'll try to solve it. Do you get how I could do a rewrite? 6 to the x equals 0. You tell me. A lot of people think you can put 6 to the 0 power and it'll equal 0, but it wouldn't. 6 to the 0 power is actually 1. So what the heck power would this have to be? There is no power that would do that. So that should remind you that you can't have a 0 here. You can't have negative numbers or 0 in the middle of a log problem. The base and the argument, these numbers here, they can't be 0 or negatives. So what's the answer to this question then? No solution. If you write this, I would accept it. Okay? Can't have a negative or a 0 in that spot. How about this? Log base 6 of 1. Remember these patterns? Apparently not. You got to get these down. When there's a 1 in the argument, it's 0. Because 6 to the 0 is 1. I know, these are confusing. It's okay. You're trying. All right, so how about this? 5 to the x equals 4. What? Is the x alone yet? No. Then your first step should be, okay, is there a way to just simply solve it? I could make the bases the same. Oh, I guess I can't. So the number one strategy you got to be able to do is rewrite. I was doing the rewrites the other way. Now you got to do a rewrite where you make the answer a log. Go ahead, make this into a log. Log base something of something. There's a lot to know for this next test. Write the word log, if nothing else. Some of you haven't moved your finger yet. That's annoying. Write log. And then figure out, what would the base have to be? And then what number comes next? All right. Out of these numbers, what do you think the base should be? 5. So then the base of this is 5. And then you remember that we never do them in order. We always go full circle. 5, 4 equals x. So the log base 5 of 4 equals x. Let me ask you. Some kids don't get why it's solved. It's solved because the x is what? It's by itself. It's alone. X is alone. So this is the answer. Now, granted, I don't know that one in my head. But if I had a calculator, I could get the answer. Or if I could make these bases the same, I would. And a lot of times on the test, we'll make these come out nice, where it'll be like log base 5 of 25 equals x. And you'll have solved it, and then hopefully you won't just write that. Hopefully you'll go, oh, this is one of those where I can make this into 5 squared. So it's the actual answer. 2. All right, so let's try this one. Log base 3 of x equals 2. Solve. Solve means get the x alone. In a moment, I'm going to ask you to turn it and show it to the kid next to you. So get this rewritten, and that should pretty much solve it all in one step, pretty much. I'm going to pause. You should have said this to the this equals this. Notice the full circle thing. 3 to the second equals x. X is 9. Raise your hand if you had that one right. Okay, good. How about this? This is where the log has the x in the base. Let me think. Solve. It's always a rewrite. Today could be called rewrite to solve, because you pretty much always do a rewrite, and then usually if you do it right, the x is alone right off the bat. Or sometimes you need one more step. Okay, compare with the kid sitting next to you. See if you rewrote it the same way they did. Check yet? Did you check yet? Yes, you. Apparently not. He's your partner. Check with him. Got to get on your game here, man. I don't know what's going on. Don't bring your stuff. You're wearing your jacket still. Half asleep. Only writing down every other problem. I've been paying attention. I'm watching you. Yeah, okay. Okay, good. All right, so here we go. X to the second equals 25. Is that done? Well, it's close. I got to just put it to the what? Square root, also known as the 1/2 power. And then remember that this is absolute value of x, and therefore there's 2 answers. Oh, so many things to go wrong in this test. I bet a lot of people said 5, didn't you? Anybody remember it was positive and negative 5? Anybody in the whole room? 3 of you. Nice job. It's so easy to forget. When you put it to a fraction power, if it's an even one, you get an absolute value of x, which then means there's 2 answers. X equals regular 5 and x equals negative 5. You want to Prove it, Mr. Server. Okay, well, I'm going to go back and put in the -5. See? Wait a minute. A lot of you didn't even know that there was a -5 for an answer. But then when you actually try the -5, what happened? It didn't work. So here's why some of you would have got it wrong. It's because you got to identify it as a solution and then realize that sometimes when you actually put it in, based on where the x is, if the x is in the argument or the base, you can't be negative. So this one's called an extraneous solution. Not only some of you forgot to identify it, then you would have had to identify it and then say it's extraneous and cross it off. Thankfully, the test isn't tomorrow. Yes, question? No, because the typical kid, didn't even remember that there was an answer of -5. So just because you forgot to do it shouldn't give you the credit. You understand what I'm saying? Because I have two kids. One writes down this, and I know, oh, they knew their crap. They knew that when they did a fraction power on both sides, that they get an absolute value, and they knew then that that answer should be negative, and then they knew to check it, and yeah. And the other kid who just says the answer is 5, 99 times out of 100, it's because they forgot to even check that -5 would work or not. They didn't even remember there was a -5 answer. So when there's extraneous, you have to say what the extraneous was. It's kind of like the other kind of problem where there was no solution. If a kid just goes, I got this really hard problem, and then I like try a bunch of stuff and then I say no solution, that won't get credit. Because if you don't know why there's no solution, you don't get the credit for just saying no solution. Yes? When there's an even root, see this part right here? When there's a fraction power, the bottom part, that's the root. If that number is even, if you do an even root on both sides, that's when you get 2 answers. When this is even. So again, the easiest one of them all is like that. And when you'd solve that, you know it's square root of, but it's also known as a fraction power. When you do a fraction power where it's even, this would have 2 answers. And in this case, they actually both work. Because when I put them back in, they actually would work. The original question was x squared equals 16. And yeah, both 4 and -4 work. But if you're putting it in a log, if this question had been log base x of 16 equals 2, then they wouldn't have both worked. The one that was negative would have had to been thrown out. Yes, I see your hand.
Wait, so what if it's a log problem first, then you switch it? You rewrite it?
Remember, the original question is what matters. Yes, so if it starts as a log question, you have to go back to the original to see if it worked. And on the last test, I thought for sure they would have an extraneous one on there. And a lot of you thought there was one, and the only one that was extraneous, I think, was the R4, if I remember right. There was an answer when it was extraneous. But there was an actual answer that worked on the R4 also. So some of you thought you had it by like, oh, it's extraneous, and then, well, that was kind of right, but there was also an answer that actually worked on the R4. So, okay, anyway. So let's get to the actual like meat of this, and like here's a typical question that's more complicated because they're making the bases more complicated. It's not that bad. This blue one here, rewrite that. It's scarier looking, but it's still the same rewrite process. This to the this equals that. Rewrite that right now on your iPad. To the power of 5 equals 239. I totally get that you Wouldn't know this one without a calculator. And it does show a little calculator over here as a little hint. So don't even take it out, because on the homework, I'm pretty sure they're all no calculator. So I'll be your calculator on this one. In fact, actually, it's probably somebody who already did it. Somebody just tell me what the fifth. We're going to have to do fifth root. Anybody know the fifth root of 239 yet? All right, I got it then. It is 2.99. That's close enough. I'm going to call it 3. So when I put this to the 1/5 power, that part comes out to be 3. So then that canceled that. And oh wait, did I just do an even root or an odd root? I did an odd root, so I don't have to worry about it. It's only even ones that can burn me on that. 3x plus 1 equals 3, and I subtract 1, 3x equals 2, and then I get x equals 2/3. And granted, I did round a little bit in there, but it came out to about 2/3. All right. This one, the black one underneath, log base 25 of 27. This guy. Rewrite to solve it. It's pretty much going to always be rewrites today. Try rewriting that one. Stop looking at the ingredients. Rewrite. I only need you with me for another couple minutes and we'll be done. Did you get 25 to the x equals 27? And you know what? This is such a trap because kids get stuck and then they're like, what do I do to solve now? Well, what's wrong with what just happened there? It was already solved. This one was already done. It was x equals. So when you rewrote this one, you didn't make it better. You didn't get it, the x alone. The x already was alone. So what's the answer? That's the answer. And if you had to put it in a calculator, do you remember what you'd type? Log 27 divided by, 27 looks funny, I'm going to try again. Log 27 divided by log 25. You have to know how to put it in a calculator. So a typical test question like this, since we don't allow calculators on it, would be, how would you have put it in your calculator? So the kid would, first of all, be trapped if they wrote 25 to the x equals 27, because they'll be like, well, how do I solve it now? Because it already was solved in the first place. And then the other thing the kid would have to know is how to put that in a calculator. And it's backwards, you know. 25 doesn't go in first, but 27 does. Log 27 divided by log 25. Now, one more thing. I want to give you a name for that. That's called a base change. I want you to think about this. That had a base of 25, and this seems like it doesn't have a base at all. But when I say log 25, and I don't even say a base, what base is it? It's the most common base of them all. I said it on the first day, but it's been a long time since then. Base 10. Your calculator operates in base 10. So we just did a base change from base 25. I think anybody, if I'd asked them, what's the base, you'd have said 25. To here, where nobody remembered what the base, well, maybe one person, somebody in the back was saying 10. That one has a base 10. Did I change the base from 25 to 10? Yeah, I did. How about this? Log base 6 of 13. What's the log base right now? 6. What if I wanted it to be base 10 so I could put it in a calculator? Write what you think you'd have if you wanted it in base 10. By the way, if you write no base at all, that's putting it in base 10. If you don't have a base, that assumes you're using base 10. Another way to say it is, how would you put it in the calculator? Because the calculator uses base 10. Did you write log 13 over log 6? Raise your hand if you did. Awesome. If you didn't, pay attention. That's how you do it. And that puts it in base what? 10. So that was a base change. Why do we use base 10? Because the calculator uses base 10. Now, here's the thing that is really hard to understand, but it's true. And my smartest students will get this. I could have made it base 100, and it would be exactly the same. Because it's scale, the bigger your base is, the smaller your answers are, and both of them are getting scaled down. So it's okay to have any base here. The only reason we choose base 10 is the calculator likes it. If I wanted it to be base 70, I could say it's base 70, and it's the same thing. When I make the base really big, the answers both get really small. Since it's a fraction, since you're dividing them, it's just the ratio. So this can be any base you want. So here's a good ACT question. Change this to base 14. And a lot of kids would be like, I have no idea. I bet you that only 1 out of every 10 kids on the ACT would get that one right. But you could. It's log 13 over log 6. But that would be base 10. So since you can pick any base you want, it'll just scale the number up or down. Both of the numbers will get bigger or smaller. It'll be the same. So if they say make it base 14, then I just put a 14 there. There, it's in base 14. You can make it any base you want. Okay. Even E? Oh yes, any base you want, even E. What the heck is E again? 2 point, what, about? 2.7, get that one memorized. It's on your calculator, but you won't have your calculator. Log base E is the same as ln. This is the same. Why? Because natural logs, they're called, log natural, is one of the most common logs that there is. And you know, mathematicians often like to clean things up and make it a little cleaner and simpler to write. Just like the square root sign. You know, technically you should have all this time been writing a little 2 there. But they say, you know what, let's just make it so that if you're going to do a square root, you don't even put one. That'll be the standard, the common square root. We simplify it. We don't even put the 2 there. Same thing with the common log. They just let you write log 10 because that means base 10 if you don't put a base. And again, a shortcut, they say, is if you want to have log base E, you can write ln. So my advice to you is, and this is, I've seen a lot of questions now, because we do this in pre-calc and in this class. If this is ever in the question, half of the question is just to catch you. Do you know what that means? And so you rewrite it, because if it's no base in the problem, it'll become all about the base. So if you have an ln, you write it as log base E, because the E will be critical, otherwise you won't get the problem right. That'll be half the question is, does the kid know enough to write their ln's as log base E's? And then, do you remember this pattern, for instance? It might turn into one of these, where if you just know the pattern, it's like, boom! The answer's 15. Do you remember this kind? If this and this are the same, then the answer's 15. Let's do another one like that. 5 to the log base 5 of 14. What's the answer to that one? 14. It's the bases are the same. The answer's already there. This is a base, that's a base, and that's the answer. All right, now that was a lot of stuff. I get it. It's a Monday. You're tired. You barely are even awake. But we reviewed everything that we've learned about logs so far. And a typical homework question for tonight looks like that. Yeah. Actually, that's one of the harder ones. But first thing I would want you to be able to do is write that as a 5 to a power. This involves all kinds of stuff you've already learned. You can't afford to just say, that was 2 weeks ago. I don't remember that. This is 5. How do I make a 125? 5 to the what? 5 to the third would have been close. So it's negative third. 5 to the negative third. So this is log base 5 of 5 to the negative third is equal to 2x minus 6. So the first step was, could you rewrite this into this? And then, why was that important? I hope you've caught this by now. This whole thing can be replaced with one simple number, -3. So -3 is 2x minus 6. And if you can't solve it from there, go back to algebra class, because this is higher algebra. I love that when we're done with the complicated problem, we end up with an algebra problem. And it's like, oh, it's easy from there. Back in algebra class, that's the hard part, is taking this part and solving it. Okay, how about this one? My guess is we can make these bases the same if we're smart about it, because it's already solved. X is alone. So then it's all about, can I make 2/7 into 4/49 somehow, so that this can be log base 4/49 of 4/49 to a power. You get what I'm saying? If I get these the same, my answer will just be the power. So what power is it? 4/49 to the, what do you think? Second power. 4/49 to the second would make it really, really big. I don't think that's what you mean. Kind of like the opposite of second, sort of. But we want to write it as a 4/49. So my question is, 4/49 to the what would be 2/7? 4/49 squared is not 2/7. There you go. 4/49 to the 1/2 power is 2/7. Do you see that this is now equal to that? And now that's a legal substitution. We just swapped out 2/7 for 4/49 to the 1/2. Then, since the bases are the same, the answer is the exponent. So what's x equal to? 1/2. Try this one without me. Hint, you want to do something with this 1/12 that gets it to be an 8 to a power. Ooh, that's icky. Remember, 8s and 2s are related. Let's pause for a second, see if you can figure this one out. Work on making the 1/12 into 8 to a power. I hope there's nothing this hard in the test, or most kids aren't going to get it right. All right, log base 8 of 8 to the something is equal to x over 2 plus 5. If I can get this, it'll be easy, because then this will just be a number. If I can just get this power, 8 to the what would be 1/12. Well, off to the side, you could even make a little problem for yourself. 8 to the what, it's probably a fraction exponent, has to equal 1/12. Well, first of all, the 1 over thing. What's that a hint that the power has to be? Negative. It has to be a negative power. 8 to the negative something. 8 to the negative, and it's probably a fraction power. All right? You get, we probably need to scale it down to be a 2. You know what I mean? Because 2 and 8s kind of go together. Okay, too much. Your brains are fried. It's okay. You're not ready for that. But by Friday, you will be. All right. This one, much simpler. Did you figure it out? I think you're right, but we're going to go back to this kind because I need to rebuild your confidence after I just destroyed it. Okay. X to the what? This is a rewrite now. X to the 4/5 equals, full circle, 27. Would you know how to solve that? Yeah. You put it to the power of 5/4. Who's extra smart and noticed something? A bunch of people. What is it? There's two answers. Because why? Even root on both sides. Absolute value of x. But who's even smarter? The negative one can't work. Because why? Because it's the x is the base, and the bases aren't allowed to be negative. So even though there is a negative answer, it's actually extraneous. Whew! Sometimes this class has seemed easy. This is not one of those days. This is honors, ladies and gentlemen. We would never try this in regular. Just wouldn't even try. This would not be done. We would not be doing this part. First of all, you don't have to have logs in higher algebra. So having logs at all is like a question. I think they'll have logs in higher algebra, but they would never have these complicated fractions, fraction powers, negative fraction powers. That stuff would be out. They might do this kind of stuff. They'd probably do that because 4 could be written as 2 squared. And then they don't even have to do that. You could just go 2 to the x equals 4 and solve it that way. And then most kids can do that, right? Okay, so you're in honor. So all I'm trying to say is this is tough stuff, and it's okay. It's supposed to be hard, and it's not like you test this tomorrow. You got plenty of time. All right, your homework for tonight is the evens. I'm going to pause to pull it up. Okay, this is the key for it, but that's okay. You're going to be doing the evens. On this problem, you see the teacher's work. What was their first step? You you rewrite it. And I think the teacher messed up right away. Yep. It should be x to the what? X to the negative 1 is equal to 15. And then how do you get a negative 1 power off of there? Put it to the what? Negative 1. And that will be 15 to the negative 1. What the heck is 15 to the negative 1? Do you understand what a negative 1 power means? It's 1 over. So x equals 1 over 15. Yes, there's a mistake in the very first question. I will repost a key in a minute. Yes, sir. Let's see if the first one's messed up too. 2x squared equals 36. That was right. And then you put it to the 1/2 power. And it's plus and minus 6, but you're right. I bet you what you're about to say. Now say it. One of those is extraneous. You can't have the negative x, so you're right. The ideal answer is x equals 6 and x equals negative 6. And then, oops, can't write a 6. There. And then you go extraneous. Teacher didn't catch it. You caught it. Good job. So again, I know that there's a mistake or two on this key, and I'm going to fix it. And I'll repost it. Probably within the next 15 minutes. Okay, so evens only. Check the answer key. Learn from your mistakes. If all you do is copy the answer key, you won't be learning much. You really shouldn't look at this key until you're done with your assignment, or at least until you're done with a couple problems, and then maybe go check. It's probably smarter to check after a couple problems, because what if you're doing it wrong the whole time? So do a couple problems, check, see if you're doing them right. That's all I got for you for today.